All right, 2.10 is pretty much the same as 2.9, except it's oriented along y instead of along z. But in case you didn't watch my 2.9, I'll go through this one also. So what they want is for us to find the expectation values for each of our spin operators, and then the uncertainties for each of the operators. So as a reminder, I wrote out all the operators here in matrix form. In order to find the expectation value, we can sandwich our operator in between our bra and ket for our state. Here's the equation for the standard deviation or the uncertainty. So we're going to have to find the expectation value of our operator squared. And then also I wrote out the up state for in the along y in both bra ket notation and then or really this is the ket, but and then in matrix form also. So along for the sy operator, we can do that in bra ket. That's pretty simple. So if we again do this, so we have up along y, and we'll do our sy operator. And then we know that if we apply our sy operator to our up state for y, we're going to get h bar over 2 along with our up state back again. And we know this because this is one of our eigenvalues for this operator. So then we just have to add on the bra for that. Then we can just pull out that h bar over 2. And then we're left with up and up. These are both along y. So this cancels out. That's just equal to 1. And so then we know our expectation value for sy is going to be h bar over 2. Which we kind of knew that. If it's oriented in up, then we're going to measure h bar over 2 100% of the time. We always expect that to be h bar over 2. All right, so let's go ahead and then let's do our sz. And for this, I'm going to do a matrix form. I don't happen to know off the top of my head what if you apply the sz operator to up in the y, what we get out of that. So I'm going to have to do some matrix stuff anyways. So we'll go ahead and do this. So we have our bra for our y, which is here. So we have 1 over root 2, 1, and then negative I. We have our sz operator, which is right here, h bar over 2, 1, 0, 0, negative 1. And then we have our ket for up y, which is 1 over root 2, 1, and positive I. All right, so let's go ahead and pull these out here. It looks like we have a 1/2 and an h bar over 2, so that's going to be h bar over 4. And let's do this one first. It's going to give us 1 plus 0 is 1. And 0, we have negative 1 times negative I. It's going to give us a positive I. And that's going to be times 1 and then positive I. That's going to give us h bar over 4. And then we have 1 and 1 plus I times I. That's going to give us negative 1. So 1 minus 1 is going to equal 0. So sz, expected value, is going to be 0. That's not saying that if we check along the z direction that we're going to measure a 0. We'll never measure a 0 along z. We're going to measure either negative h bar over 2 half the time and positive h bar over 2 half the time. So if you average out all those measurements, you're going to get 0. It's just a mix of negative and positive h bar over 2s. So we expect that to also be the case for sx, but we'll do the calculations. So we have 1 over root 2, 1, and negative I. We have our sx operator, h bar over 2, 0, 1, 1, 0, and 1 over root 2, 1 positive I for our ket. All right, so pull all these three out, and again, we're going to get h bar over 4. All right, so we have 0 plus negative I, looks like negative I. And then we'll have 1 plus 0 is 1. and then 1 and positive I, equals, we'll have our h bar over 4, and we'll have negative I plus I, it looks like, and that's going to be 0 also. So expectation value for Sx is going to be 0. Same reason, we're going to have a mix of negative h bar over 2 and positive h bar over 2. All right, so in order to get the standard deviation, or the uncertainty, we're going to have to get this term here, which is going to be our operator squared, and the expectation value of that with our operator squared. So we'll start with y again, squared. So that's going to be our up bra for y, and then 2 of these sy's, which will be 2 h bar over 2's. And then up in y again. Again, once we pull out the h bar over 2 squared, we'll be left with 1. So sy squared expectation value is going to be h bar over 2 squared. All right, so let's do sz next, I guess. So we'll do this in matrix form again. So 1 over root 2, 1 and negative I. We're going to have 2 of these sz operators. So h bar over 2, 1, 0, 0, negative 1. And again, h bar over 2, 1, 0, 0, negative 1. And then our ket, which is 1 and positive I. All right, so, and don't forget our 1 over root 2. All right, so let's pull out all these here. So we're going to have 1/2, and we're going to have h bar over 2 squared. So h bar over 2 squared and 1/2. All right, and then we'll have, it's going to be a row vector, make it smaller. So we'll have 1 plus 0 is 1. We'll have 0, negative I times negative 1 will be positive I. And then we have this operator again. So 1, 0, 0, negative 1, and 1 I. All right, so it looks like we'll have, I'll keep this here, h bar over 2 squared, 1/2. And let's see, so we have 1 plus 0 is 1. And we'll have 0 plus, we have a negative 1 and an I would make a negative I. So negative I and 1 and I. And so we'll have h bar over 2 squared, we'll have a 1/2. And then we'll have 1 times 1 is 1. And then we'll have a negative I squared, so it'll be positive 1, so it'll be plus 1. And so this will be 2, and that'll cancel out with our 1/2. We'll be left with, and this is our sz squared. Expectation value would be h bar over 2 squared. And because that one was h bar over 2 squared, we can probably assume that sx will be also, but go ahead and go through that. So 1 over root 2, 1 negative I, and then 2 of these sx operators. So h bar over 2, 0, 1, 1, 0, h bar over 2, 0, 1, 1, 0, and then our ket, which is 1 over root 2, 1, and positive I. All right, pull out all these again, and we're once again going to get h bar over 2 squared along with a 1/2. Okay, so we do these first this time. I don't know, mixing it up, I guess. So 1 and negative I. And then we're going to have, let's see, so 0 plus 1 is 1. 0 plus 0 is 0. 0 plus 0 is 0. And 1 plus 0 is 1. And then 1 and positive I. And this will leave us with 1 times 1 is 1, plus 0 is 1. And we have 0 plus negative I will give us a negative I. And then 1 and I. And we'll bring this down also. So this is going to be h bar over 2 squared, a 1/2. And this is going to be 1. And then we have negative I and negative I. Well, I squared, negative I squared, again, will be positive 1. And again, that'll cancel out. And that'll once again be sx squared. Expectation value will be h bar over 2 squared. Okay, so now we have all the values we need to calculate the uncertainty. So let's do the uncertainty for sy. And that's going to be the square root of our sy squared, which is h bar over 2 squared, minus our expectation value squared, which is, again, h bar over 2 squared. We can see that this is going to be 0. This minus this is 0, square root is 0. So our delta sy is equal to 0. All right, and then for our sz, write this out. It's going to be square root of, so we're doing sz, so this one squared is h bar over 2 squared, minus, and then there's going to be 0. So this is going to give us h bar over 2. So delta sz is going to give us h bar over 2. So this is this is expected. So it's going to be we're expecting a 0 with an uncertainty of h bar over 2, which means that we're going to be about h bar over 2 off each measurement, which is true. We're either going to be it's either going to be negative h bar over 2 or positive h bar over 2. So we're going to be off by a factor of we're going to be off by h bar over 2 for each reading. So again, for sx, it's the same value. So h bar over 2 minus 0 is again going to be h bar over 2. So delta sx is equal to h bar over 2 also. All right, so those are all of our values there. Those are our expectation values. And here's our uncertainties there. It also asks to draw some vector diagram. And I think what that's wanting is if we have our z-axis here, our y-axis here, our x-axis here. This is really hard to draw, but if you can imagine, so our y-axis is going to extend in this direction here, and somewhere along y we're going to have a negative h bar over 2. Somewhere along this axis we're going to have a positive h bar over 2. And same here, on the z-axis we're going to have a positive h bar over 2. And then we're going to have a negative h bar over 2. And same with x, like here and here. Our x is going into the board and out of the board, so this is kind of hard to draw. But we know that our y's are going to be, well, all of our measurements are going to be plus or minus h bar over 2. So we could have, let's say we have positive h bar over 2 in the y, and positive h bar over 2 in the z, and positive h bar over 2 in the x. So that's hard to draw because it's going to be out of the screen and like up here somewhere. So like here and out of the screen. And then we might have, then we might have like positive h bar over 2 in the y, negative h bar over 2 in the z, and then that could be like in the screen h bar over 2 or out of the screen h bar over 2 along x. But basically what you end up getting is are these values. So we might have vectors here, might have vectors here, and it's kind of spinning around there. Same with negative h bar over 2, where you kind of get this circle here, where it's going, it could be anywhere between negative h bar over 2 and positive h bar over 2 in the z and x, but it's staying there in the negative h bar over 2. If it's oriented in negative h bar over 2, it's going to stay in negative h bar over 2. So hard to draw, but hopefully you get the idea of what that's going for.